You know, we talk about the heart all the time, as a symbol for love and emotion. But for this explainer, we're going to look at it for what it really is, an absolutely incredible, non-stop biological machine. A perpetual pump that works tirelessly from before we're even born until our very last breath.
And the amount of work it does? It's just staggering. Get this. Every single day, the average adult heart pumps about 2,000 gallons of blood. To give you some perspective, that's like filling up a normal bathtub more than 40 times. Your entire blood supply circulates through your heart every single minute. You're just sitting there. It's wild.
So that brings up the big question, right? How? How on earth does this muscle, which only weighs about a pound, pull off such a huge task, day in and day out, without ever getting a break?
Well, the best way to understand it is to follow the action. So that's what we're going to do. We're going to trace the path of a single drop of blood as it travels through the heart's two main circuits. Think of it like a microscopic delivery service, and we've got a front row seat.
Okay, so our journey starts on the right side of the heart. This is what's known as the pulmonary circuit, and its mission is simple. Take all the blood that's just come back from the body, blood that's low on oxygen, and get it over to the lungs for a fresh tank. But first, you got to know the layout. The heart is basically a duplex apartment with 4 rooms, or chambers. You've got 2 on the right, 2 on the left. The top chambers are called the atria, and the bottom, much more powerful chambers are the ventricles. These 4 rooms are the main stops on our blood drops tour. All right, here we go. Our drop of deoxygenated blood, just finishing its lap around the body, flows into the right atrium. This is kind of like the heart's main lobby or receiving room. From there, it goes through a one-way door, the tricuspid valve, and drops down into the right ventricle. Now this is a pumping chamber. When it squeezes, it's going to send that blood on to the next stop, the lungs. But wait a second, what actually tells that ventricle to pump? What creates that powerful, perfectly timed squeeze? It isn't just muscle. There's a whole electrical command center running the show from behind the scenes. And that command center is the heart's own internal conduction system. You can think of it as the heart's built-in wiring. It generates and sends out the electrical signals that tell the muscle exactly when it's time to contract. Now, this wiring gives the heart one of its most amazing properties, autorhythmicity. It's a fancy word, but it just means the heart can generate its own beat, all by itself, without any go signal from the brain. It's why a transplanted heart, which has had all its nerves from the body cut, can still beat on its own. It's pretty incredible. And that signal follows a very specific route. It starts at what's called the SA node. That's the heart's natural pacemaker. From there, it travels to the AV node, which does something absolutely genius. It pauses. It creates this tiny delay. And that little pause gives the atria just enough time to finish squeezing all their blood down into the ventricles before the ventricles get the signal to pump. Then, the signal zips down the bundle branches and out through the Purkinje fibers, triggering a massive coordinated squeeze from the bottom up. And you can actually watch this whole electrical journey play out on an ECG. You know, that wavy line you see in movies? Each one of those bumps tells a part of the story. That first little P wave, that's the atria contracting. That big spike, the QRS complex, that's the powerful squeeze of the ventricles. And the final T wave is just the ventricles resetting, getting ready for the very next beat. It's a live look at the heart's electrical system in action. Okay, so let's get back to our little drop of blood. It just went to the lungs, it dropped off its carbon dioxide, picked up a fresh load of oxygen, and now it's headed back to the heart. It's ready for Act 2, the big one, the systemic circuit. This is the journey to deliver that fresh oxygen to every single cell in your entire body. So this fresh, oxygen-rich blood comes into the left atrium. It passes through another one-way door, the bicuspid valve, and into the absolute powerhouse of the heart, the left ventricle. When this chamber contracts, it pushes that blood out with incredible force into the aorta, which is the body's main highway, to start its long journey. And if you're wondering why the left ventricle is such a powerhouse, it all comes down to its job. The right ventricle, it only has to pump blood right next door to the lungs. It's a short, low-pressure trip. But the left ventricle has to generate enough force to push blood through the entire body, all the way to your brain and down to your toes. And to do that, its muscular wall is way, way thicker and stronger. So, we've got the plumbing and we've got the electrical. Now, let's put them together and see how they create that familiar lub-dub rhythm of a heartbeat. It's called the cardiac cycle. Every single cycle has two main phases. The first one is systole. This is the work phase. It's when the heart muscle is actively contracting, squeezing down, and pushing blood out of the chambers. Systole is the squeeze.
The second phase is diastole. This is the relaxation phase. And it might sound kind of passive, but it is absolutely essential. Diastole is when the chambers relax and fill back up with blood, getting ready for that next big push. If you don't have a good filling phase, the pump has nothing to pump out. Diastole is the reload.
So what about the sounds we hear? When a doctor listens with a stethoscope, that first lub sound isn't actually the muscle contracting. No, it's the sound of those first two doors, the tricuspid and bicuspid valves, slamming shut. This happens right when the ventricles start to squeeze, and it stops blood from going backward.
And the second sound, the dub, happens right after. That's the sound of the second set of doors, the aortic and pulmonary valves, snapping shut as the ventricles relax. This makes sure blood that just got pumped out doesn't come flowing back in. So, lub-dub, it's just the sound of four doors opening and closing, all in perfect time.
But there's one last, really cool detail. Your heart doesn't run at 100% capacity all the time. It's way too smart for that. It has a hidden gear, you could say, called cardiac reserve. This is the extra power your heart can tap into when you need it, like when you're running or you're under stress. It's the gap between what it does at rest and its absolute maximum output.
So this incredible organ inside you has the built-in ability to rise to a challenge, to pump 4, 5, even 8 times more blood when you ask it to. It literally holds the power for your peak performance. Which kind of leaves us with one final thought. What are you reserving yours for?